When we talk about stress, we usually describe it as an emotion. I feel overwhelmed, I'm burnt out, I'm stressed, I'm tired. But did you know that stress actually reorganized your brain? And that made me curious about what stress actually does inside the brain. So, for my first project, I explored the chronic stress chain and how brain networks are being organized. But first, to understand stress, we need to learn the HPA axis, which is a system that's responsible for releasing cortisol. Cortisol is useful in short-term situations because it prepares the brain and body to react quickly to certain threats. But when cortisol is being triggered too much, which essentially causes the chronic stress, it begins to affect how different brain regions communicate. Research consistently shows three main patterns. 1. The prefrontal cortex, who's responsible for decision-making and emotional regulation, and under chronic stress, it becomes less active. 2. Amygdala detects the threats and becomes more active, and we don't want that. And 3. The hippocampus, which supports the memory and learning, and under chronic stress, it can also shrink over the time. But amongst all, what really fascinated me was stress does more than just affecting the brain regions. It also affects the network and how each of these connections interact. And now, let's talk about my project. I decided to analyze a synthetic fMRI data and rebuild a simplified model of these network changes. My initial goal with this project was to understand how functional connectivity shifts when stress becomes dominant and persistent. And what emerged from this analysis is that stress behaves less like a temporary signal and more like a redistribution of neural resources. In other words, the brain begins prioritizing survival and threat monitoring over reflection, planning, and long-term thinking. Through my 3D modeling and data that I've gathered, this was the result I've got. But this raised a much bigger question for me. If chronic stress reorganizes the brain, could we detect that shift early? And that question led to my second replicate project. I'll see you in the next one. Bye.